Welcome to queenon7.com. Please like, share and subscribe my video. Today we're going to learn about the covalent bonding. We have learned ionic bonding in the previous video. Covalent bonding is slightly different from the ionic bonding. When two non-metals react with each other, they actually make a covalent bond. And the definition of a covalent bond is when two non-metals share an electron. For example, carbon, when it is going to make a bond with hydrogen, that bond is actually because carbon is going to share one electron with hydrogen. Carbon is in the fourth group, so it will make 4 bonds. So you can write down 4 hydrogen there. So carbon will share 1 electron with each hydrogen. You can also represent the covalent bond with the line, the solid line, and that's how you're going to represent that. Now we're going to look at the periodic table first, and we're going to look at how it looks like on the periodic table. So I'm going to remove that, and I will come back to that, and I will show you how to draw a dot and cross diagram. When you look at the periodic table, this is how it looks like, and there are columns in the periodic table. You can see that first, second, third, fourth, fifth, 6, 7, 8. In the new periodic table, this is 13, this is 14, 15, because the subgroup in between, they were used to be subgroup, but now they are known as the proper groups. So do not get confused if you get a new periodic table and it says 13, 14, 15. You're just still going to use the same concept, because if you consider this as 3, 4, 5, 6, 7, 8, it will give you a lot of information to understand the chemistry of the elements. Now, after group 3, most of this area, all of this, where you have carbon, nitrogen, oxygen, fluorine, and neon, all of these are called non-metals. And this area, all of this area, is called metals. Non-metals, most likely they are going to be liquid. Some of them they are solid and most of them they are gases. Some of them they are liquid or solid. Metals are always solid except mercury. Mercury is liquid at room temperature. When we're going to look at the bonding, for example, you look at, before I started, you need to understand what is meant by 1, 2, 3, 4, 5, 6 and 7. So if you find out for example, if you have fluorine there and you say hydrogen, which is obviously in the group 1, or we normally write it right on the top, it has only 1 electron. So we draw only 1 shell and we put that electron there. Sometimes they place it in the group 1 because it has 1 electron in the outer shell. So we use this dot to represent the electron. Then you have another non-metal, because hydrogen itself is a non-metal. You can take chlorine. Chlorine is just under fluorine. Now, anything which present in group 1 will have 1 electron in the outer shell. Anything which is actually present in group 2, 3, 4, 5 will have 2, 3, 4, 5, 6, 7 electrons in the outer shell. What it means is, when you look at the periodic table, you will see there's a small number and there's a big number on the element. The small number represents number of electrons and protons. So this number is a total number of electrons you have in an element. Now, what you're going to do is, you're going to write down the law. The law is, in the first, for the GCSE, you say 288 is the rule. So in the first shell you have 2 electrons, in the second you 8, and third is 8 as well. And then you will follow this rule to complete the 17 electrons in chlorine. So you are going to draw like this. In the first one, 2 electrons. In the second one, you have 8 electrons. And out of 17, 2 have gone into the group shell number 1. 8 have gone into the second shell. So 10 are already gone. Then you have left with 7 electrons, which will be in the last shell. Now the rule is the maximum you can have actually 8 electrons in the second or third shell. It requires 1 more electron, so it will actually make 1 bond. So this is how you're going to write it. If you have an element which you can write as 17, I will personally, you sometimes struggle to draw these. If you follow 288, that's fine. If you do not remember that and you don't want to draw this, you can look at 17 and you can say 2, 8 and 7. That makes it 17 anyway. Okay. Now chlorine, which has got 1 electron, requires 1 electron to make it 8. So total number of electrons in the outer shell, so the outer electrons or valence electrons, that's another word you need to learn. It has 7 electrons in the outer shell. Maximum it can have 8 electrons. So 8 minus 7 is equal to 1. That means chlorine will make only 1 bond. Let's talk about carbon. Carbon belongs to the 4th group. It has atomic number of 6, so that means 2 and 4 is the electronic configuration. 2 electrons in the first shell, then 4 in the last shell. Now 4 are the number of electrons it has in the outer shell. It can have maximum of 8. You minus it by 4, and this is how many number of bonds carbon can make. Let's go for nitrogen. Nitrogen belongs to the 5th group. Its atomic number is 7. If you write down the electronic configuration is 2 and 5. 2 in the first one, 5 in the second one. So 8 electrons it can have maximum in the outer electron. So 8, but it has only 5. So 8 minus 5 is equal to 3. So nitrogen will make 3 bonds in total. And same goes for rest of them. If you want to follow that, for example, if you want to take an example of oxygen, which is quite famous, oxygen's atomic number is 8 and 2 and 6. So 6 electron in the last shell. So total number of electron it can have according to this rule 8 in the second shell. So 8 minus 6, the outer electrons, you will have 2. That means oxygen can make 2 bonds maximum. Now let's have a look if we can draw some examples which are required for your GCSE. Now if they say show a bonding between hydrogen and chlorine, I would personally go back to periodic table. I would say hydrogen has 1, and then they will say, oh, this is chlorine, and they will just draw the last shell. You need to go back on periodic table and look at that what is the position of chlorine. If it's in the column number 7, it has 7 electrons in the outer shell. Please represent the electron of one atom with dot and other with the cross to distinguish. Now when they're going to come close together, they both are non-metals. When they're going to come close together, hydrogen has got only 1 shell, and in the first shell the maximum you can have is are 2 electrons, and chlorine can have 8. They both will join together. This is a technique you use. You draw 2 circles with a shared area. Hydrogen will share 1 electron. Chlorine has 7 electrons, but maximum it can have 8 electrons, so it can make only 1 bond. So it will share 1 electron out of 7. Then you will have rest of them outside of the shared area. This is very important. A lot of people just write down here 7 electrons. 1 is already shared out of 7. Rest of the 6 will be written outside of the shared area in oxygen. in chlorine. Now this is called a pure covalent bond. Now covalent bond can be different. You can have 2, 3, 4. We will have a look some examples if you wanted to look at. For example, if you have oxygen. Oxygen has an atomic number of 8. So it means it has 2 in the first shell, 6 in the last shell. Total number of electrons in the last shell or valence shell is 6. It can have maximum of 8. So you can say 8 minus 6, that means 2. Oxygen can make 2 bonds. Now we know it is. If they say, can you draw a structure of oxygen molecule, that means there are 2 oxygen atoms are reacting together and make a bond. So you put another oxygen there. They may not give you any of the electrons in the outer shells. You have to draw it yourself. So you look at the periodic table. Now, if you look at it, when you see the both of the atoms in front of you, you must be thinking, oh, how I'm going to draw that. The first thing you will do, you draw a shared area of the 2 circles and you put oxygen in the middle. You do know that they both have got 6 electrons in the outer shell, and the maximum bond they can make, they have to make 2 bonds anyway, and that means they have to share 2 electrons whenever they're going to make a bond with other. So that means this oxygen will share 2 electrons and this oxygen will share 2 electrons as well, based on the formula, because it has 6 in the outer shell and requires 2 more bonds. For each bond you need 1 electron, so for 2 bonds you need 2 electrons. Then you draw those electrons in the outer shell and you will count them to make sure that you didn't make any mistake. 2, 4, 6, 8. So these 4 electrons will be counted for this oxygen, and they also counted for this oxygen as well. When you count the electrons for this oxygen, 2, 4, 6, 8. So now it is stable. Then you got this one, 2, 4, 6, 8. This is stable, and that's how it looks like oxygen molecule. I'm just going to do quickly one more example of carbon dioxide, which is very famous. That if you have carbon dioxide, for example, carbon belongs to the 4th group. Its atomic number is 6. So it is 2 and 4. It means it has 4 electrons in the outer shell. Maximum it can have 8 electrons in the outer shell, but it has only 4. So 8 minus 4, that will make it 4. Now, if this number, which is actually came from by subtracting the outer electrons from the maximum number of electrons it can have, will tell you exactly how many bonds it's going to make. So that number tells you carbon can have 4 bonds. Based on that, carbon has got 4 electrons in the outer shell. I'm just going to draw it just slightly there. So if I'm asking you to draw carbon dioxide, this is carbon, this is oxygen. I want you to draw it. So it's completely empty. So you will look back, go back on periodic table, see it's column number 4. So you will write down 4 electrons in the outer shell of carbon. Then you will go back to oxygen. Oxygen has 6 electrons in the outer shell. So you leave it there as it is. These are the normal atoms. Once you draw these 3 atoms, you will see that carbon can make 4 bonds, whereas oxygen, which has got 6 electrons in the outer shell, can only make 2 bonds, because it has 2 electrons in the outer shell, 6 electrons in the outer shell. It requires 2 more only, so it will only share 2 of its electron out of 6. So what's going to happen now is they will actually share, carbon will share 2 of the electron with the oxygen on this side, and it will share 2 electrons on this side. So I'm just going to remove this and I'll draw a shared circle, and this is oxygen, and you write down carbon has 4 electrons. All of the 4s are actually shared, so you do not need to write down any other electrons out of the shared area. They are already utilized. Now carbon has 4 plus 4, 8 is stable. You have to achieve 8 electrons in the outer shell, whether they are shared or lone pair. Then you have oxygen. Oxygen has 6 in total, 2 are shared. Then you can have 2 more like that and 2 over there. So that 2, 4, 6, 8. Oxygen is stable. Same go for oxygen. Out of 6, 2 are already shared. So 4 left behind. And that's how you explain the covalent bonding. Now covalent bond, when they make it, these bonds, you represent with the solid line because there are 2 bonds, so you will represent with the 2 lines. They are very strong, so these bonds are very strong, and you require high energy to break them. But they have low melting point and boiling point. The strength of the covalent bond has got nothing to do with the melting point and boiling point. The melting point and boiling point is a physical property, and it totally depends on the intermolecular force. That means if you have one molecule of carbon dioxide, between carbon and oxygen you have a covalent bond, but another carbon dioxide molecule, they do not say that, oh, they have. If they ask you why covalent compounds have a low melting and boiling point, you can say that they have a weak intermolecular force. So you do need to say weak intermolecular force. Do not say that they have weak bond. That's incorrect, because a bond is actually between the 2 atoms when they share the electron. So you have to say for this force that it has weak intermolecular forces. You don't use the word of the bond, okay? Because they are very weak, that's why it has low melting point and boiling point. All right. In the next video, I will explain the joint covalent structure, which have high melting point and boiling point. Thank you very much.